Okay, so for this one, we have to find V here and the current I here. So first thing, we have two nodes here. Let's call it V1 and V2. But notice that when we do the node equation, the current passing in this section will be difficult to find because let's write the equation. So it'll be V1 plus 9 volts because as the current passes through the voltage source, it leaves out of the positive terminal, so it's increasing by 9. So V1 plus 9 equals V2. But there's no way to find what the current will be equal to. So if this current is equal to I, for example, how can we use this to find I? We really can't. So what we're going to do is, since we have this equation written down, we're going to ignore this 9 voltage source, okay, and treat this as one supernode. So that means all the current that's entering from this area or leaving is equal to all the current that's entering from this area and leaving, okay? So let's start by writing current directions. Let's call this I1. Hold on. I1. This is I2. This one is just I because we have the direction right here. And then this one is I3. Right? So we see everything is pretty much leaving this giant supernode. So let's write it down. Node V1 and V2. We see everyone is leaving. So it'll be I1 plus I2 plus I plus I3. Now let's find equations to substitute for these I's. So I1, it will be equal to V1 minus 21 volts over 4 because it goes from a high potential to a low potential, and the low potential here is 21 volts, and it passes through the 4 ohm resistor. So it'll be V1 minus 21 over 4. Now let's find I2. I2 will be V1. Recall this is the ground node, so it'll be 0 volts. So V1 minus 0, which all over 3. Now I3 will be V2 minus 0 all over 6. And then I will be V2 minus 0 all over 2. Now we can use this as a substitute for the equation we have here. So it'll be V1 minus 21 over 4 plus V1 over 3 plus V2 over 2 plus V2 over 6. Alright, so V1 over 4 plus V1 over 3, that's 0.58333 V1. And then 1 over 2 V1 plus 1 over 6 V2, that's 0.666 V2. And then we have minus 21 over 4, which is minus 5.25. Now we have two unknowns, but we can use this equation that we had before to solve for that unknown. So let's plug V2 with V1 plus 9. So it'll be 0.58333 V1 plus 0.666 V1 plus 9 minus 5.25. Okay, so if you distribute 0.666 into V1 plus 9, we get the following. Alright, we get the following answer. And then if we collect like terms, we get 1.25 V1 plus 0.75. Now we can solve for V1. So notice this is equal to 0. So if we bring 0.75 to the other side, it'll be minus 0.75. Divide both sides by 1.25. So it's 0.75 divided by 1.25. Sorry, minus 0.75 all over 1.25, which is minus 0.6. Now we can use that to solve for V2. It's not actually asking for V2. It's asking for V and I. Okay, V1 is, so we're trying to find this V here, but this V is equal to V1 because pretty much as the current moves this way, it drops to 0, and the only way for it to drop to 0 is if V1 is equal to this, because if V1 is equal to minus 0.65, then minus 0.65 minus 0.65 is 0. So this V has to be minus 0.65, okay? Now let's solve for I. Notice that I would be equivalent to this, okay? So we have to find V2, and we can find V2 using this. So we know V2 is equal to minus 0.6 plus 9, which is 8.4. And now we have now we have V2. So V2 is 8.4. Divide that by 2, and we have I equals 4.2. So we know what V is. V is minus 0.6 volts, and I is 4.2 amps.